When you see a Boeing 747 soaring through the sky, you think passenger jets, commercial aviation, the queen of the skies carrying hundreds of travelers to distant destinations. But what if I told you that some of the most extraordinary Boeing aircraft never carried a single paying passenger? Instead, they carried space shuttles on their backs, fired megawatt lasers at ballistic missiles, and served as flying observatories peering into the birth of stars. This is the untold story of Boeing's secret legacy. 7 remarkable projects that transformed the humble jumbo jet into humanity's most versatile flying machine. From NASA's space program to America's nuclear command centers, these aircraft pushed the boundaries of what was thought possible, hidden in plain sight above our heads. Today, we uncover the classified missions, the billion-dollar experiments, and the engineering marvels that prove Boeing's true legacy extends far beyond commercial aviation. To understand these extraordinary adaptations, we must first appreciate what made the Boeing 747 revolutionary. When it first took flight in 1969, the 747 wasn't just an aircraft, it was an engineering philosophy made manifest. Its massive size, unprecedented payload capacity, and robust design created a platform that Boeing's engineers would exploit in ways never originally imagined. The 747's raised cockpit design, initially intended to accommodate freight loading through the nose, would prove crucial for mounting space shuttles. Its cavernous interior could house laser systems the size of school buses. Its high-altitude capabilities made it ideal for astronomical observations above Earth's atmospheric interference. But perhaps most importantly, the 747's structural integrity could withstand modifications that would tear apart lesser aircraft. Boeing had unknowingly created the Swiss Army knife of aviation, a platform so versatile that NASA, the military, and specialized agencies would continuously find new ways to repurpose it for humanity's most ambitious projects. The first and perhaps most iconic transformation began in 1974, when NASA faced an impossible challenge. The Space Shuttle program was nearing reality, but there was one critical problem. How do you transport a 100,000-pound space shuttle across the country when it can't fly on its own power? NASA's solution was audacious. Modify a Boeing 747 to carry the shuttle piggyback style. But this wasn't simply bolting a spacecraft to an airliner. Engineers had to completely reimagine the 747's aerodynamics, structural integrity, and control systems. 2 former American Airlines 747s were selected for this unprecedented conversion. NASA 905 and NASA 911 underwent modifications so extensive they were essentially rebuilt from the inside out. 3 massive mounting struts were installed on the fuselage, 1 forward, 2 aft, each engineered to withstand forces no commercial aircraft was ever designed to handle. The real challenge came with flight dynamics. Adding a space shuttle fundamentally altered the 747's aerodynamics, creating dangerous yaw instabilities. Boeing's solution was elegant. Vertical tip fins added to the horizontal stabilizers, providing the additional control authority needed to keep this aerial giant stable. From 1977 to 2012, these Space Shuttle Carrier Aircraft became the unsung heroes of America's space program, ferrying shuttles from landing sites back to Kennedy Space Center for refurbishment. They didn't just transport spacecraft, they transported dreams. While NASA was using 747s to support space exploration, the military was envisioning something far more aggressive, turning Boeing's jumbo jet into a flying weapon of unprecedented power. The YAL-1 Airborne Laser program represented the Pentagon's most ambitious attempt to create a real-life Death Star. The concept was deceptively simple. Mount a megawatt-class laser in a modified 747 and use it to shoot down ballistic missiles during their most vulnerable boost phase. But the reality was staggeringly complex. 6 sedan-sized modules, each weighing 6,500 kilograms, had to be crammed into the aircraft's interior. These modules housed a chemical oxygen iodine laser system so sophisticated it required its own team of PhD scientists to operate. The YAL-1 wasn't just a weapon. It was a flying laboratory that pushed the boundaries of physics, optics, and aerospace engineering. Its beam control system could track and engage targets hundreds of kilometers away, compensating for atmospheric distortion, aircraft movement, and target evasion in real time. In 2010, the impossible became reality. The YAL-1 successfully intercepted and destroyed a ballistic missile in flight, proving that science fiction could become science fact. But success came at a price. nearly $2 billion and 2 decades of development. In 2011, shifting priorities and budget constraints ended the program, but its technological legacy lives on in today's directed energy weapons research. Not all of Boeing's 747 transformations were born from military ambition or space exploration. Sometimes they emerged from tragedy and the desperate need to save lives. In 2002, 2 aging air tankers crashed during firefighting operations, killing their crews and highlighting the dangerous inadequacy of existing aerial firefighting capabilities. The solution would come from an unlikely source, converting passenger 747s into the world's largest firefighting aircraft. The 747 Supertanker was engineering audacity at its finest. These converted jumbo jets could carry 19,600 gallons of fire retardant, more than 8 times the capacity of traditional air tankers. But capacity was only part of the equation. The real innovation lay in the pressurized dispensing system that could deliver this massive payload with surgical precision. Racing at 600 kilometers per hour, these aerial giants could reach fire zones across continents, delivering their life-saving cargo exactly where it was needed most. From Arizona's devastating wallow fire to California's catastrophic Camp Fire, the supertankers battled some of history's most destructive blazes. The sight of a 747 dropping a crimson waterfall of retardant became a symbol of hope for communities threatened by wildfire. These aircraft didn't just fight fires, they fought fear, offering proof that human ingenuity could stand against nature's fury. Though the last supertanker ceased operations in 2021, its legacy endures in the lives saved, the communities protected, and the demonstration that sometimes the most powerful weapons against destruction are repurposed tools of peace. Dr. Sarah Morrison, former SOFIA project scientist, explains what made this next transformation so revolutionary. People don't realize that most of the universe is invisible from Earth's surface. Our atmosphere blocks infrared light, the very wavelengths that reveal how stars are born, how planets form, and how galaxies evolve. We needed to get above that atmospheric blanket. The Stratospheric Observatory for Infrared Astronomy, or SOFIA, represented one of the most elegant solutions in scientific history. Take a Boeing 747 SP, cut a 4-meter hole in its side, install a 2.7-meter reflecting telescope, and fly it at 45,000 feet, above 99% of Earth's infrared blocking atmosphere. But SOFIA was more than just a flying telescope. It was a collaboration between NASA and the German Aerospace Center that pushed international cooperation to new heights. The aircraft itself was a shortened 747 SP, chosen for its ability to reach higher altitudes and longer ranges than standard variants. Inside SOFIA's pressurized cabin, teams of astronomers and engineers worked in shifts during flights that could last up to 10 hours. While the telescope observed through that unsealed cavity in the fuselage, scientists controlled cutting-edge instruments and collected data that would reshape our understanding of the cosmos. SOFIA's discoveries were profound. The first detection of the universe's first type of molecule, new insights into star formation, and detailed observations of phenomena impossible to study from ground-based observatories. When SOFIA concluded operations in 2022, it had fundamentally changed astronomy, proving that sometimes the best way to reach the stars is to fly toward them. Of all Boeing's 747 transformations, none carry the weight of responsibility like the E-4B, America's Doomsday Plane. This is where engineering meets the unthinkable, where the versatility of Boeing's design confronts humanity's darkest scenarios. 4 heavily modified 747-200Bs serve as the National Airborne Operations Center, designed to ensure government continuity in the event of nuclear war or catastrophic national emergency. These aren't just aircraft. They're flying bunkers, mobile command centers that could literally carry the fate of the nation in their aluminum shell. The E-4B's most critical feature is what it doesn't have: digital electronics. In an age of sophisticated computers, these aircraft rely on analog systems immune to electromagnetic pulses that would cripple modern technology. It's a deliberate step backward in time to ensure functionality when everything else fails. With unlimited range through aerial refueling, accommodations for 112 people, and communication systems that can reach anywhere on Earth, the E-4B represents the ultimate insurance policy. It's proof that Boeing's platform could be adapted for humanity's most critical mission, survival itself. These aircraft shadow presidential movements, stand ready during international crises, and serve as FEMA command centers during natural disasters. They're simultaneously America's most important aircraft and ones we pray will never need to fulfill their primary mission. The most famous Boeing 747 variants of all carry the call sign that needs no introduction, Air Force One. Two VC-25A aircraft, essentially flying White Houses, represent the pinnacle of Boeing's adaptability applied to presidential transport. These aren't merely luxurious aircraft. They're mobile command centers designed to keep the president connected to the world no matter where duty calls. Advanced communication systems, defensive countermeasures, unlimited range through aerial refueling, and the ability to function as a complete government facility make Air Force One the ultimate expression of Boeing's versatile platform. From the Boeing 707 that first carried presidents in the 1960s to today's 747-based fleet, Boeing has been entrusted with America's most precious cargo, its leadership. The upcoming VC-25B, based on the 747-8, will continue this legacy into the 2030s and beyond. 7 extraordinary transformations. 7 proof points that engineering excellence knows no boundaries. From carrying space shuttles to firing lasers, from fighting fires to exploring stars, from ensuring national survival to transporting presidents, Boeing's 747 platform achieves something unprecedented in aviation history. These projects represent more than technological achievement. They embody human adaptability, the courage to reimagine existing solutions for unprecedented challenges, and the understanding that true innovation often comes not from building something entirely new, but from seeing existing capabilities through revolutionary eyes. As the 747 era winds down in commercial aviation, its legacy lives on in these specialized variants. They remind us that the greatest platforms aren't just those that do one thing well. They're the ones versatile enough to do things their creators never imagined. Boeing's hidden legacy teaches us that sometimes the most profound innovations happen not in the laboratory, but in the moment when someone looks at the familiar and asks, "What else could this become?"